and I'm going to put it into full screen so that it is. All right, I'm not going to finish that sentence. Does everybody feel okay with honor lock, or does somebody want me to show you where honor lock is on our Blackboard? You're okay? There's a whole tab, and what I would start with is the PDF for how to download honor lock, okay? And then on the day of the exam, go to Carl Albert honor lock to get the exam password. So you'll have My Math Lab open, and you'll open the exam, or open the honor lock exam, and it will put in the password for you. Again, if you're at the Academic Resource Center, do not need honor lock. They do it for you. Good. Okay. Bit of a tangent. So a polynomial is one variable is an algebraic expression of this form. So what it has is terms. We take those terms, we add them, and we subtract them. Okay. Addition and subtraction of terms. So when you hear terms, do you think of like maybe like terms, right? Like terms, unlike terms. Here are 1, 2, 3, 4, 5, 6 terms. Okay, so this is a 6-term polynomial. Good. Okay. The standard form means that the polynomial is arranged with exponents in descending order. Okay. The exponents are these guys, this 5, this 4, this 3, this 2. The 7x actually has an understood 1, okay? And you could even think of that 2 as being multiplied times x to the power of 0, okay? So here we have x to the 5th, 4th, 3rd, 2nd, 1st, and 0 power, because did you know that anything raised to the 0 power is 1? Good. So 2 times, if that x was maybe 8 to the 0 power, is just going to be 2, because it's the same as 2 times 1. So they are in descending order. They're going from the highest number to the lowest number. Good. The terms are the expressions that are separated by addition and subtraction. So we're adding these two terms, we're subtracting these two terms, we're adding this term, we're adding this term, and then we're subtracting this term from the whole thing. Good. Coefficients are these parts. The 3 of the 3x to the 5th is a coefficient. The 4 of the 4x to the 4th is a coefficient. It's the number in front of the variable. Good. The coefficient of the term, and again, only write down what you need to know, okay? Of the term 7x is 7. Does that make sense? It's the number in front of the variable. The constant is the number with no variable, even though I said that that no variable was actually x to the 0. The constant is 2 for this polynomial. It's not. It's -2. As I stare at it, the constant is -2. Did anybody else catch that before I did? So what can we say? We can say that this polynomial has 6 terms. We can say that the constant of this polynomial is -2. when the polynomial is in standard form, as this one is, the leading term is just the first term, the first entire term, okay? The first term of the polynomial in standard form is 3x to the 5th. So the difference between a coefficient and a leading term is the term is the whole thing, 3x to the 5th. The coefficient of 3x to the 5th is the 3. Okay. So each of these has a coefficient. The coefficient of 3x to the 5th is 3. The coefficient of 4x to the 4th is 4. The coefficient of negative x to the 3rd is actually negative 1. Good. The degree is the largest exponent, okay? So the degree is usually the degree, well, it is the degree of the leading term in standard form. Good. So this, we can, the way I say it is this is a polynomial of degree, okay? This is a polynomial of degree. And if you just look at it, what is the largest exponent? Just the exponent, not the base of that exponent. 5. This is a polynomial of degree 5. The leading term is 3x to the 5th. The constant is negative 2, and it has 6 terms. Any questions? Okay. Just to be clear, standard form, if you had x plus 3x squared, to put it into standard form, is 3x squared plus x. So I've switched them, not because of the 3, but because of the squared. The exponents are in descending order. All right, so remember, the leading term is the first term, the degree is the degree of the exponent, and the constant is the last term when it's in descending order and when it has a constant. Okay, the constant will never have a variable. Like the word constant, always the same, okay? No matter what the variable is, it won't change. Ah, no, I did not mean to share my screen. Okay, sorry, my screen was dark and I was worried your guys' screen was dark. I'll do that all the time. First thing you want to do if you're finding the leading term is to make sure that you already have it in standard form or in descending order, okay? So this is x to the 3rd, x squared, x, and then a constant, x squared, and then a constant minus x plus x squared. So this one needs to go into standard form. I'm just going to put it over here or below it. So the largest exponent is the squared. Then we have so this is x to the 2nd power, then we have x to the first power, and then we have a constant. The constant does not have a negative in front of it, so it's a plus. The negative 2x, or sorry, the minus 2x, the minus stays with the 2. And then here we have x to the first power, and then the constant is the square root of 2. So this is the only one that was not in standard form. The leading term, again, if we look back here, the leading term is the first term, so not just the number, the whole term of the polynomial when it's in standard form. So the leading term here is going to be the negative 6x to the 3rd, 4x squared for this one, positive x squared for this one, and 5x for this one. Negative 6x to the 3rd, 4x squared, x squared, and then 5x. Good? All right, degree. If we look back at what degree means, the degree is just the largest exponent. If it's in standard form, it's going to be this number, right? The highest power of the leading term. Understood 1. Good. So it would also be this guy, right? So this is a 3rd degree polynomial. This is a 2nd degree polynomial. Also a 2nd degree polynomial, and this is a 1st degree polynomial. Because anything raised to the 1st power is itself. Constant is the part of the polynomial that has no x in this case, or no variable. The constant here is 1. The constant here is -3. The constant here is +9. And here it's oh, I didn't need to put that plus sign. Got caught up for that -3. And then square root of 2. Any questions? Do not be shy. If you have a question, other people have a question. Even in the live class, we can get. You can find a way to communicate it. Good. All right. So now that we know what a polynomial is and some of the parts of a polynomial, let's practice adding polynomials. Then we will subtract some polynomials, multiply polynomials, and then 2 division problems, okay? Not my favorite, but you'll be proud when you do it. Okay, to add polynomials, collect like terms. And we know terms is just each part that is separated by the negative sign or the positive sign. What I do is I put the polynomials, so you have these two, you're just combining them, okay? It'll be very different when we have to subtract one of the polynomials from the other, but when you're just combining them, they're kind of all, it's like one big polynomial, right? We just put a big plus right here. Good. And so what I do is I like to rewrite it and I put the polynomials in order, okay? So you can put it in alphabetical order if you had more than one variable. And then you can put it in descending order of, remember, the exponents are the important part, okay? Not the 7 and the 5 and the 4 and the 3 and the 2, but this power, okay? So if I were to rewrite this, I would start with 4x to the 4th, okay? And then I have a plus 7x to the 3rd minus 3x to the 3rd. Doesn't matter if that's in front or that's in front, okay? So I've used that one just to keep myself clear. Minus x squared plus 2x squared plus 5x. Oh gosh. You guys still there? Oh.
Yeah, we're still here.
I apologize. Somehow my FaceTime got connected to my computer and a phone just started ringing. I thought that I had hung up on Zoom. Panic. All right. Sorry, guys. Plus 5x plus 2x minus 1. All right, now it's in order. Now you just combine like terms. So we know that these two are alike. I'll take the sign in front of it too. We know that these two are alike. And then we know that these two are alike. So that, I'm going to go way down here, would be rewritten as 4x to the 4th. A positive 7 minus 3 is 4, right? Tell me if I'm wrong. Keep the sign, keep the exponent. And then a negative 1, right? You could even put 1 there if you want. Negative 1 plus 2 is just plus 1, which I don't like to write the 1, I just put the letter. And then 5x plus 2x is 7x. Any questions, or did I make a mistake? I might have made a mistake. 4x to the fourth plus 4x cubed plus x squared plus 7x minus 1 for A. Good. All right, same thing for B. We'll just take 3x to the fifth plus x to the third plus 2x to the third. And if you're better at this than me, like you don't have to do all of these steps. When you're taking notes, only take the notes you need, okay? So now it's in order. And again, you can just take x to the third plus 2x to the third, negative 4x squared minus 5x squared, plus 6x minus 2x, minus 3 plus 1 becomes 3x to the fifth plus 2 and 1 is 3x to the third. A negative 4 combined with a negative 5, 4 and 5 is 9, and it's negative because those were both negative, right? X squared. Positive 6 minus 2, so you're just taking 6 and you're subtracting 2. You get 4x. Negative 3 plus 1 is negative 2. Or you could say 3 minus 1 is 2, and the bigger sign, the bigger number had the negative sign. So anytime you have two different signs, you're subtracting the smaller number from the bigger number, and you're keeping the sign of the bigger number. Good. So that was adding. Now subtracting. So the first thing you want to do when you're subtracting is imagine that this is a negative 1. Okay, so you're taking that entire second polynomial and you're multiplying by a negative 1. Or you can also look at it as changing the sign of each term of the second polynomial. Okay, so I'm either multiplying by negative 1 or I'm just taking that positive 3, changing it to a negative 3. Negative 9 becomes positive, negative 5 becomes positive, and 3 becomes negative. Good. All right, I'll come down here. So for A, we had 4x to the fourth minus 5x cubed plus 7x squared minus 2. Now I'm going to take all of those, change the sign. So negative 1 times a positive 3 becomes negative 3x to the fourth. Negative 1 times a negative 9 becomes a positive 9x squared. Negative 1 times negative 5 becomes positive 5x. Negative 1 times a positive 3 becomes minus 3. So I multiplied by negative 1, or I changed the sign. Positive, positive, negative. Now, same thing as we did before, put it in order. So that becomes 4x to the fourth minus 3x to the fourth minus 5x to the third plus 7x squared minus 5x minus 2 minus 3. I already wrote that wrong because I was looking at the wrong one. Plus 5x. Combine those two. Those two. Those two. Good. So 4 minus 3 is just 1. I ignore the 1 and just put the letter. Minus 5x to the third. 7 minus 9 is going to be negative 2. Minus 2 minus 3. So we're just combining them. 2 and 3 is 5. And they were both negative. So it's a negative 5. I did something wrong. Thanks. Thank you. That's a 16. All right. Plus 5x minus 5. Any other mistakes you guys see? Good job. Thank you. All right. And letter B. 3x to the third minus 5x squared minus 8. Now again, this pen's already dead. I don't know why I always pick it up. That positive 3x to the fourth is going to be multiplied by a -1, so it's going to be minus 3x to the fourth. You're going to take a -1 and multiply it by the -7, so I'm going to get a positive 7x to the third. Negative times a positive is a -5x. Negative times a -1 gives me a +1. So that is now, that has been distributed. We distributed that negative to the 3, the -7, the +5, and the -1. Now we can combine, oh, sorry, put it in order. -3x to the fourth is what I'm starting with because it's the biggest exponent. That look okay? Now I can combine the 3 and the 7 and the -8 and +1. So 3 and 7 are both positive, so that's 11 x to the third. -8 plus 1, so 8 minus 1 is 7, but the 8 is a negative, so it's a -7. No, 7, 8, 9, 10. Two mistakes. All right, just also to be clear, let me give you an example of like terms, right? 2x squared plus 5x squared is 7x squared. But if I had like 2x squared y plus 5x squared, I cannot simplify that because that one has a y. So they have to have the same exponents raised to the same powers to actually be like terms. Unlike. And these are like. So that's adding and subtracting. Now we're going to multiply and then we're going to divide, okay? When multiplying polynomials, use the distributive property and then simplify. Remember when multiplying variables to add the exponents, okay? So when you're multiplying, for example, 5x squared times 3x, I think of the 5 and the 3 as being multiplied together, and then I think of the x squared and the x as being multiplied together, okay? So 5 times 3 would be 15, x squared times x. When multiplying variables, add the exponents. So the rule of exponents for, I think it's like it n to the power of, x to the power of n times x to the power of m is x, look at me, you're running out of room, n plus m, right? That's what they mean by add the exponents. So 5 times 3 is 15, x squared times x to the first power is x to the third, because 2 plus 1 is 3. So let's carry on. I don't like it when I have like nothing underneath the papers. All right, so distributive property means I take, for example, here we're just FOILing, right? So we're going to take the first term 3x, we're going to multiply it by x squared, then we're going to multiply it by -2x, then we're going to multiply it by a +3. And I know I'm going to run out of space. I'm just going to start down here. 3x plus 4. X squared minus 2x plus 3. So 3x times x squared is going to give me 3x to the third, right? The 3x times the negative 2x is going to give me negative 6, because 3 times a negative 2 is a negative 6. And then x to the first times x to the first, that's like saying 1 plus 1 is 2, right? And then 3x times positive 3, 3 times 3 is 9. And then just carry that x, because it's just 1x. Good? And then we'll take that 4. The 4 times the x squared, positive 4x squared. The 4 times the negative 2x, 4 times negative 2 is negative 8. And then you just carry that x on. And then 4 times 3, they're both positive, so it's a positive 12. Now we're just adding polynomials. So we first multiply them all the way through. First multiply the 3x by those 3 terms. Then we multiply the 4 by those 3 terms. Then we have something that we can just add together like we were doing before. So that will be 3x to the third minus 6x squared plus 4x squared plus 9x minus 8x plus 12. Negative 6 plus 4, positive 9 minus 8. Negative 6x squared plus 4x squared is negative 2x squared. Positive 9 minus 8 just leaves us with 1, right? 9 minus 8 is 1. And then the 12. Final answer for part A. And A was kind of the hardest one, interestingly enough. B, we have 5x squared times the quantity 3x plus 4. So this is a monomial times a binomial, right? 2 terms. The 5x squared times 3x, 5 times 3 is 15. X squared times x is x to the third. And then the 5x squared times 4, 5 times 4 is 20. X squared. Good. C, sorry, I called A foiling because I thought that that second polynomial had 2 terms, but it had 3. This one's actual foiling. X plus 3 quantity times quantity x minus 2. X times x is x squared. X times negative 2, negative 2x. Now on to the 3. 3 times x is a 3x. They're both positive, so I'm going to add it. 3 times negative 2 is a negative 6. There are 2 terms I can combine, the 2 middle terms. So that becomes x squared. Negative 2 plus 3 is just x minus 6. Not like terms. Our last one, we're just taking a negative x and we're distributing it through that polynomial. So it's a bit like multiplying it all by -1 like we were doing in the subtracting polynomials part, but instead of -1, it's actually a negative x. So that's going to be x to the third, that's going to be x squared, and we're going to add an x. So we're adding an x and changing a sign. I feel like saying that just complicates it though. So a negative x times a positive x squared, that's a 1, right? A negative times a positive is a negative, and then 1 plus 2 is 3. Here I have a negative x to the first times a positive x to the first. A negative times a positive is a negative. The first power and the first power added together give me a squared. And here's a negative x times a negative 1. Negative times a negative becomes a positive. 1 times an x is just an x. Any questions about that last one? Maybe that one's the hardest. I changed my mind. A was the longest, but that one is the most difficult. And speaking of most difficult, I think this is the most difficult thing we do in this entire class, using long division to divide polynomials. Do you remember long division? I might get a blank paper just because I can see through this one. Okay. When dividing polynomials, use long division. So the first thing you want to do is make sure that it's in standard form. 3, so that doesn't matter when you're multiplying them, but when you're dividing them, it does. 3x to the third minus x squared plus x minus 2, x plus 2. 4, 2, 1, 0, 2, 0. Okay, so it's in standard form. Now let's talk about long division. Do you remember long division? If I have the number 52 and I want to divide it by 3, long division was like make a house, right? What we do with those numbers is we take the first, this is only a single digit, right? And so we take that first digit of 52 and we try to divide try to divide 5 by 3, right? How many times does 3 go into 5? 3 one time is 3, 3 two times is 6, right? 6 is above 5. So we say 3 goes into 5 one time. We put that one above the 5, right above the 5. And then what do we do with that 3? We multiply it, with that 1, we multiply it by the 3 and put it below the 5. 1 times 3 is a positive 3, right? Now, very important, we subtract it, okay? So we said, how many times does this go into this? Wrote it up here, took that number, multiplied it by everything over here, and wrote it here. Now we're subtracting it from the top number. 5 minus 3 is 2. And as we know, 3 doesn't go into 2 at all. So then you bring down your next term. Now I have a 22, right? How many times does 3 go into 22? 3, 6, 9, 12, all right? 3 times 7 is 21, right? So 3 goes into 22 7 times. 7 times 3 is 21. And remember, then you have to subtract that. 22 minus 21 is 1, right? So we say remainder 1. There's actually another way to write it. You can say 17 remainder 1, or you can say 17 and 1 over 3. So you can put the remainder over what you were originally dividing by. Let's look at it. 52 divided by 3 is 17.3. 17, sorry, don't multiply. 17 and 1/3, right? Those are and, not multiply. 17 and 1/3 is the same. So your remainder goes over what you were dividing it by. So basically that's long division. It's difficult, and now we're going to do it with polynomials. First thing I'm going to do, I made sure it was in standard form. Now I'm going to put this guy outside the house, x plus 2. And inside the house, I'm going to put this term, this polynomial, 3x cubed minus x squared plus x minus 2. And I'm going to do the same thing I did with the 32 and the 3. So I'm going to look at that first term, 3x cubed, and I'm only going to look at the x and the 3x squared. What do I need to do to x to make it equal 3x, or sorry, what do I need to multiply x by to get 3x squared? I need to multiply it by 3x, that's cubed, sorry, squared. If I multiply this by this, I get that. True? Okay, so that's how I decided that I'm using 3x squared. Because I said, what do I need to multiply x by to get exactly this number? Good. If I multiply this now by everything and write it right here, that's my first step done. I know this is very difficult. So 3x squared times x gives me 3x to the third, and then I have to do it times that positive 2 as well. So 3x squared times 2 is a positive 6x squared. So what I did there was I distributed the 3x squared to the x and to the 2. This one goes with this one goes with this one. Okay. Now remember, we are subtracting both of those. So that's a negative 3x cubed, and that's a negative 6x squared. You can rewrite it if you want. Minus 3x cubed minus 6x squared. Okay, to distribute that minus sign. 3x cubed minus 3x cubed is 0, right? Which is what we wanted. Negative x squared minus 6x squared is negative 7x squared. Good. Because this has two terms, I'm going to bring down that positive x. Like that. Now, what I did up here with the 3x cubed, I'm going to do with the negative 7x squared. So I say, what do I need to do to x? What do I need to multiply x by to get negative 7x squared? Negative 7x. Good. Now I take that negative 7x, multiply it by x. Negative 7x squared. Negative 7x by positive 2 minus 14x. Any questions? Now remember, we are making this, we are subtracting this or changing the sign of both of those. So we could rewrite this as plus 7x squared plus 14x, right? So both of these was just rewriting to distribute that minus sign. So now I have negative 7x squared plus 7x squared. So that one is nothing. You could also write 0. That's confusing to just have a big slash out of nowhere. That's 0, right? Negative 7 plus 7, 0. Positive x plus 14x becomes 15x. Good. Look at, you're doing it. We're doing it. We're doing it. That has two terms. So I'm going to bring down, it's a negative 2. Good. Now remember, we're only ever looking at the x and the first term. So to get 15x from x, I multiply it by a positive 15. Now I take that 15, I multiply it by the x. 15 times x is a positive 15x. 15 times a positive 2 is a positive 30, right? Now I need to subtract those. So that becomes negative 15x minus 30. So positive 15x minus 15x, another 0. Negative 2 minus 30, negative 32. I can't go any further. And x won't go into 32, right? At all. So I say remainder 32. If they ask for the remainder, which I think is what my math lab does, 90% sure, or that would be a minus sign, sorry. I should have put it lower. Minus 32 over x plus 2. I'm going to try the last one. Last one is 5x to the fourth minus x squared plus x minus 2 divided by x squared plus 2. All right. Oh, 4 minutes. So we have x squared. We need, I like to say plus 0x plus 2. I like to have a placeholder for each of the x's because otherwise it can get a little confusing if this one doesn't skip them and this one skips them. So this will be 5x to the fourth plus 0x to the third minus x squared plus x minus 2. So I added that just so we could go 4, 3, 2, 1, 0, 2, 1, 0. Good. So we'll do the same thing, just looking at the x squared and the 5x to the fourth. I need to multiply the x squared by 5x squared, right? 5x squared times x squared will give me 5x to the fourth. 5x squared plus 0 will give me 0x cubed. 5x squared times 2 is going to give me 10x squared. So that's 0. That's 0. Oh, sorry. Remember, we have to. So that is actually negative x squared minus 10x squared. So that'll be minus 11x squared. Because this has 3 terms, I'm going to bring down both of these. Plus x minus 2. Negative 11x squared. And the x squared just means I need to multiply it by negative 11. Negative 11 times the x squared becomes negative 11x squared. Negative 11 times 0, 0x. Negative 11 times 2, negative 22. Remember, we have to, I'm saying it to myself mostly, we are subtracting that. So we're changing all of those signs. So negative 11 squared plus 11 squared is 0. X minus 0x is just x, and it was a positive x. And then negative 2 minus a negative 22, so negative 2 plus 22 is 20. Is that okay? So my answer for B is 5x squared minus 11 with a remainder of x plus 20, or you can write it as, sorry, 5x squared minus 11 plus, that's a positive, x plus 20 over x squared plus 2. And you guys are free to go. A is, I just want to rewrite that answer so that it's super clear. 3x cubed minus 7x plus 15 minus 32 over x plus 2. Or 3x squared minus 7x plus 15 remainder 32. Good? All right. I know I went over time. I appreciate it. And email me if you have any questions or stay if you have questions. I'm going to stop the recording.